All right, let's do number 13. Okay. Oh, good. Our submarine has a thermal camera. Please enter the code found on page 1 of the manual. Oh, gosh. Okay. Page 1 is a large sheet of transparent paper with random dots and instructions on how to fold it up. Cool. Fold along y equals 7, fold along x equals 5. The first section is a list of dots. Then there's a list of fold instructions. So if we fold the bottom half up, so the dots will overlap. And then if we fold the other way, now we've made a square. Okay. It's pretty big, so we'll just do the first fold. After the first fold, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. Right. Okay, I think this is pretty easy. So let's start here. And then we're gonna do, let's see. So I guess we should do a set, right? Because then we can like consolidate the ones that are the same. So let's have a point. And our input is going to be data type fold. And then fold is going to take a axis int. And an axis will either be horizontal or vertical. Okay. So what do we need to do? So what we're gonna do is parse. Yes. So first we should split paragraphs. So we'll have our dots and our folds, paragraphs, input, and our input will be a list of dots, points, and a list of folds. So split paragraphs input. Yeah, sure. We need to parse a dot. Map parse dot lines dots. Parse dot will have us let x, y. Yeah, exactly. Split. Split on parse fold. We'll need to make a fold. But that's not right. We should do lines. A string parse fold. And then, so we just have a bunch of, like, we should just drop, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, put, it's going to be drop 11. That. Drop 11. And then we need to take dir have an equal sign, and then the rest should become parster read rest. Parster just needs to take a char and give an axis, so parster x will be horizontal. Is that right? The x-axis is going to be, actually these are backwards. Okay. Parster that expected direction. Okay, I think that'll work. Let's try it. Parse test. Nope. Because we don't know how to show it. Right, deriving that. Okay, horizontal at 7, vertical at 5. Right, and then let's, so instead of a point, a list of points, let's do a set of points. And so it's going to be from list dots. Perfect. Let's try that one more time. Good. And then let's try doing a fold. So fold. And it's going to be, it's going to take a fold and a point. So fold, horizontal, what should we call this? Let's call this, so horizontal is going to be along y equals k. And then we just need to do something to the, to the x value, right? Yes, x equals k is horizontal, right? Oh my gosh. I always manage to mix up like vertical and horizontal and x and y. Okay, so if we're folding along x equals 5, that's a vertical line. So that's a vertical fold. Let's do vertical first. Oh, this is, okay. X-axis, Y-axis. Because I think it's confusing, because the fold might be horizontal, and the line will be vertical, and I'm going to get confused. So let's call this x-axis. So an x fold and a y fold, and that will be far more obvious. So if we're folding along a x, which axis? Is that right? It's really more about direction, isn't it? No, okay. So for folding on and x equals 5. So x equals 5 is a vertical line. Math is hard. Is a vertical line, and we need to change the x positions of the point. So it's going to be the absolute value of x. So it's going to end up being k minus the absolute value of x minus k, I believe. And I believe that's right too. Let's just try it. Debug. So if we're folding, let's fold x. So let's fold at x equals 3. And then let's fold the point x equals 1, y equals 5. That shouldn't change. But if we do 5, 5, that'll fold over to 1, 5 because 3 is in the middle. Okay, I feel reasonably happy about that. I don't know why that was so confusing for me, but it always manages to be. So we have less dots, fewer dots visible after the first fold. So I think we just need to map that over our set. So let's do solve A, dots, folds, fold, and we don't care what comes after. At least one fold. Format. So what do we need to do? We get the size of, it's not going to be full dots. Can we do a set dot map? I think so, right? Yeah. Fold. Oh God, we better first fold. Fold, first fold. Dots. Right? 17 dots? Okay. So I understand this is going to be pretty big, correct? But I don't see why this shouldn't work. So let's do that. Oops. 607. Okay. That was pretty easy. Let's keep going. There we are. Finish folding. Okay. And then we're gonna need to print it out, aren't we? Yeah, this is actually pretty cool because we're gonna need to like print this thing out in order to see it. So we're gonna have to do a little bit of work. But first, let's try doing all the folds. So first fold all. We'll take a set of point and do a fold. Right. What? No. There's something else called fold, isn't there? So that's okay. F. Fold. F. Okay. Oh, of course there's something else called fold. That might be a problem for us later, because that's confusing, but that's fine. And so to do all of the folds, we're going to take the dots, folds, and let's do set.size for now. Fold L, all, dots, folds. Is that right? After all folds equal that in display dots. And display is going to somehow figure out how to print out all this stuff. So let's figure out how to do that. Okay, I think we can do this. So it's gonna be display is so we need to get the display. Let's get the max x and y of the points. I don't like that. Max x equal right, and max y, yes. How are we doing this? No, I don't want to do it like that. What we're going to do is in That's not going to be an int. That's going to be, let's make it a list of strings for now. So this will type check. So our y, correct. This is going to be, let's make it the character dot for x in 0 to max x. Let's return a string. Display after all folds. Right, because it needs to be like that. And let's give ourselves some space. Okay. So instead of dot, we want to check if x, y, set dot lm points, then we'll do, what did they do? Okay, we'll do one of these, else one of those. Set dot, oh my god, member, that's it. I'm like spectacularly bad at remembering what anything is ever called in Haskell, but we did that. So let's like, for that, is there like, okay, sure. That's kind of ridiculous. Let's keep it like that. And then we just need to unlines that. And then this will just be a string. In display, let's put a, oops. Okay, is this gonna work? No, because we're like showing it instead of like printing it out. But it's on the clipboard. So does that work? That's not how that works. So let's just run it. And that's our result. We can probably just, nope, not like that. We can do that and replace it with that. And it says, oh gosh, it says CPZLPFZL, I think. Hey, we got it. All right. Well, day 13 was not too bad, except for this part where we had to like figure out what it said and figure out how to do that, because I don't really have a good way to print like nicely formatted output of strings just with the scaffolding I've built up around this. But that worked. So that was pretty straightforward. Folding was definitely easier than the graph we had to make last time. So on to day 14, I guess, and I'll see you there.